Welcome to my classroom. In this video, I'm going to talk about the introduction to quadratic functions. So let us write down our concept. Graphing quadratics. And just remember, this is an introduction video, so I would not be going into depth about the concept. I'll be giving you a basic overview of actually what quadratic functions are. Okay, so first of all, we will write down our definition of a quadratic function. So a quadratic equation is an equation with the highest power of variable. Our variable usually is x. So the highest power of the variable is 2. Now you used to see our linear equations were y equals in the form of, for example, 2x plus 1. Those were our linear equation. The highest power of x was 1. I hope you agree with me. So when that happened, students, we used to have one solution on the x-axis. Now we'll have something different here. We will be having two solutions for our x-axis. So all right. So basically, what will happen in equations like these will be, they will be in the form of y equals ax squared plus bx plus c. Now, just a reminder here that a, b, and c are numbers. And as you can see, the highest power of x is 2. What does that mean graphically? Graphically, it means that our graph, the maximum number of points where it can cross the x-axis is going to be 2. So I hope I'm making sense here, students. This is a very important concept of quadratic. The name is quadratic by the highest power is 2. And this is the reason for highest power being 2. It is actually crossing your x-axis at 2 places. That's the maximum number of x-intercepts it can have. Now, these two things where it crosses are called x-intercepts. This was our point 1, point 2. X-intercept zeros. Now, they're also called zeros of the quadratic functions, reason being at this point, your value of y becomes 0. So that is the point that we have to give our value of y to be equal to 0. That's why they are called zeros also. It's just a fancy math word to find the solution. Another way to say is also solutions of the equation. So anytime they say find the solutions, find zeros, find x-intercepts, it is the same thing. You're actually trying to find at what two places or at one place, which place is the graph crossing the x-axis. This one is your y-axis. So hopefully it's making some sense to you. Now, another important thing to keep in mind is that the shape of a quadratic graph is called a parabola. That's just another fancy name. Anytime you have a graph in the form of an upside down U or a U like this, it's called a parabola. All right, so on the next page, we'll move on to point number 4 in our note taking. So let me clear this page. So point number 4. So on point number 4, students, we need to understand other aspects of the graph. So we will look at vertex. Now, vertex of a quadratic graph is nothing but the maximum point or the minimum point of the graph. So here your vertex is minimum, and right here it's the maximum. So we can just say in our normal simple English will be, it is basically where the graph makes a turn. Now, just a reminder, your maximum or minimum, whatever point it is, it's always going to be in the form of x and y. So that's how you'll calculate your vertex. And this is going to be also the highest as well as x and y. Now, for example, we are looking at, the temperature of a place, let us say that function. So it's reaching a minimum temperature, and then when the weather changes, again, the temperature increases. Or there is a projectile in motion, and it's covering a certain distance at a certain speed. There will come a time is your x-axis, is your time axis. So there will come a time when the projectile or the moving body has attained a maximum height, or it's now going to have its speed decreased, and at a certain point the distance will be, the time will be equal to the same time it began with. So hopefully I'm making some sense, trying to make some sense of the basic quadratics. We will actually, the application of this function is a lot in calculus, and we see how the volume of a certain object is decreasing, the related rate of volumes and stuff, as compared to the time axis. So it has a lot of application, and that's why at the beginner's algebra we teach this. Next page, students, we'll talk about point number 5. So let me clear this page. All right, next up is point 5. We will talk about the axis of symmetry. So the axis of symmetry is basically like you have symmetry in nature, like for example, there's a leaf. So this line is basically the axis of symmetry, which is dividing the leaf into two equal parts. So in the same way for our graph, we also have the axis of symmetry. So let us say we have our graph going like this. So this line, let us say x equals 0, is dividing the graph into two equal parts. Or a different graph we want to see, this line x equals to 3 is dividing our graph into two equal pieces. It's making our graph symmetrical about this point on the x-axis. So hopefully that made sense too. All right, so next up we'll talk about point number 6 on the next page. Point number 6, we are looking at, I'll call it up or down parabolas. And the important thing to remember is that up or down depends on the value of a. And when your a is negative, your parabola is down, that is frown. And when your value of a first number is positive, the parabola is up, or in the form of a cup. So hopefully it made some sense, and that reminds me I gotta have some tea also.